All right. Good morning, everyone. Thank you all for showing up. I'm here to introduce Roger Dingledine. He's the project leader of the Tor project. The Tor is a piece of software that has an extremely large user base, I believe, in the neighborhood of 500,000 users. It provides anonymity to a large set of people, dissidents, government agencies, corporations, normal people, people that own tinfoil hats. And they've innovated quite a bit in the frontier of providing transport layer privacy on the internet and have spawned a great deal of research. And Roger's here to share some stories of fighting the Chinese government, Iranian government, and other fun tales.
Hi, is it okay if I use the big mic? Perfect, okay. He was making sure that I was mic'd somehow. So hi, I'm Roger, and I'm going to tell you a little bit about the Tor project today. I'm basically going to try to cram 4 or 5 talks into one talk. So all of you will be disappointed somewhat, but hopefully nobody will be disappointed entirely. So there are a lot of things we can talk about. I'm going to start off with a basic overview of what is Tor, and then we'll go from there. So Tor is online anonymity software. It's also a network of volunteers around the world who are running relays, and it's also a protocol. We have an RFC style spec that says this is how you can build your own compatible Tor client. And there are several groups in Germany who built their own compatible Tor clients, a fellow in Canada, somebody at Yale. So we try to make it really easy to be able to build software that will interact with the Tor network. Open source, freely available. One of the other neat things about Tor is the variety of communities that we have around it. About 20 years ago, in the anonymous communications research world, whenever you had an idea, I think we can attack this or we can defend this, it was always, let's think really hard about whether the attacks or defenses will actually work. And now there's actually a deployed system out there. So we're pretty much the standard, I thought about defending anonymity like this, or I thought about attacking like this. Everybody goes for Tor at this point. So we've got a lot of developers, researchers. Pretty much every university I go to these days has a computer science group who is either studying Tor or wants to study Tor. So there are an infinite number of grad students out there, and you could become one of them. Damon and Kevin are going to be doing some more Tor research here, and the more the merrier. So another interesting part of Tor is the variety of funding we've had over the years. We started out funded by the Naval Research Lab through DARPA. And from there, we were funded by the Electronic Frontier Foundation. So it's fun going to each of these different groups. For example, going up to the various DoD people and saying, the same software that you need to keep your soldiers safe in the Middle East, those crazy left-wing libertarian wackos need it for their civil liberties stuff. And then you go to the EFF people and say the same thing that you need to keep people safe on the internet, those crazy conservative right-wing wackos need it for saving their soldiers' lives over in some other country. So it's fun going to all these different groups and explaining to them that other people need it besides them. And more recently than that, we've had some funding from another U.S. government group called the International Broadcasting Bureau. They run Voice of America and Radio Free Asia, stuff like that. And then we've had some funding from the U.S. State Department, which we can certainly get into more later on. Okay, so Tor is also, as of a few years ago, a real live 501c3 nonprofit. Our budget is somewhere between $1 million and $1.5 million a year. We're funding something like 15 or 20 people at this point, many of them part-time, but still that's pretty cool. So our goal as a nonprofit, we've got a couple of goals. The first one is we want to write software that everybody around the world can use that will keep them safe on the internet for a wide variety of definitions of safe. And then the second one is we need to figure out how to explain to everybody around the world why they need this safety and how to recognize once they've got it. So there's an advocacy and educational component that makes the job even trickier. So we've got some number of users. It's an anonymity system, so it's a bit hard to tell for sure how many we've got. But I'm guessing more than 100,000 and less than 1 million people are running Tor right now. So that's a lot more than it was 3 or 4 years ago, probably. Okay, so let's take a step back. What are we actually trying to solve here? What are the problems that we can imagine? So we've got Alice over here, and she's trying to talk to some website or other internet service, Bob. Where can the adversary be? Maybe the adversary is watching Alice's local network. Maybe that's Comcast, and they want to figure out what you're doing so they can advertise to you better. Or maybe that's the Moroccan monopoly telephone company, and they just watch all their users to figure out what websites they go to, or to block them, or to track them. Or maybe the attacker is on the Bob end. Maybe somebody is watching indie media or WikiLeaks, and they really want to know who's publishing to these websites so that they can keep track of their users better. Or maybe the attacker is Bob. Maybe it's CNN.com, and they really want to know who their users are so they can advertise to them better. Or maybe the attacker is somewhere in between. Maybe it's one of the tier 1 ISPs like AT&T or something like that, and they get to watch quite a bit of the network, and so maybe they're able to correlate Alice talking to Bob. So the goal of Tor here is to make it so that no attacker can figure out that this Alice is talking to that Bob. If the attackers are in all of these different places I've been talking about, then we're screwed. We can't protect against that. And in a few more slides, I'll explain what we can do and what we can't do. Another thing to keep in mind, anonymity is not crypto. I talk to a lot of corporations who say, well, yeah, but I use a VPN, so I'm all set. I don't need this anonymity stuff. And encryption is good. You should use encryption. But even when you're using encryption, somebody can still figure out who you're talking to, how much you're talking to them, when you're talking to them. Nobody tries to break the encryption anymore in law enforcement and other agency worlds. It's all about, let's build the social network graph. Let's figure out who that guy in the middle who keeps getting talked to or keeps talking to other people is, and then we'll break into his house and install a wiretap or ask him questions or whatever we would do to get around the fact that encryption's happening. And then there are a bunch of other versions of anonymity on the internet that are not as strong as what we want. So there's the plausible deniability. There are a lot of peer-to-peer file sharing, freenet style approaches where they say, so yeah, you asked me for the file, and yeah, I gave you the file, but it might not have been me. Maybe I was relaying it for somebody else. You can't prove that it was me. That might work the first time, but what about the 40th time somebody asks for you for the file, and you're the guy who gave it, and each time you say, you can't prove it was me? Maybe in some legal systems that is a reasonable thing to go for, but I don't want China to be able to line up the 8 people and not be sure which of those 8 people it is. I want something stronger than that, where you're not even sure which user you should go look at. And then there's the single hot proxy approach. There are a lot of corporations out there who run a centralized anonymity system, and they say, yes, all the traffic goes through us, but we promise we won't look at any of the traffic. Okay, we look at all of it. We promise we won't write anything down. Okay, we log all of it. We promise we won't tell anybody what we've seen. And it's hard to know whether they are actually providing the security properties that they promise, but we want something that's not based on promises. We want something that's not based on an architecture where they could screw you, but they promise not to. Instead, we want something where the architecture itself means that there's no single point in the network that gets to learn who's talking to who. Okay, so there are a bunch of different ways that we phrase these things depending on who we're talking to. I actually only use the word anonymity when I'm talking to other researchers. When I'm talking to my parents and my grandparents, I tell them I'm working on a privacy system. When I'm talking to corporations, Google or Walmart and so on, I work on communication security or network security. Because anonymity, that's kind of scary. Privacy's dead. Security, good point. We do need security. So yeah, we need to use Tor. And then when I'm talking to governments and law enforcement, I work on traffic analysis resistant communication networks. And again, these are exactly the same security properties and exactly the same network that they're all using. But the trick is to figure out how to phrase it for them in a way that makes them realize that the security properties are something that they need. And then there's the fourth category that we learned about a few years ago and have been focusing more and more on, are people around the world who can't reach certain websites or choose not to reach them because they're under surveillance. And if there's a way that we can let them access parts of the internet or interact with other people around the world, they don't mind the security properties. For example, people last year in Iran quite liked the fact that they weren't getting arrested when they were using Tor, and people using plain text proxies were getting arrested. But really for them, it's about reachability. It's about now I can get to Facebook where before I couldn't. Okay, so there are a bunch of things that we can talk about. I'm going to do an inadequate job of all 5 of these talks for the day. And I'll be around for the rest of today and tomorrow if you want to chat more about them. So the first one is a few more examples of who uses Tor and why. We've got a lot of different users out there, and many of them come to me and say, hey, Roger, I'm using Tor for this purpose. I just wanted to let you know. And then the Tor design in a nutshell. How does it work? What security properties does it give you? A little bit about Tor and censorship and circumvention and China and Iran and Vietnam and all the other fun stuff going on. We have an NSF grant to collect data about the Tor network and users in an aggregated, safe way. And so a lot of what we're working on there is what data can you collect such that you don't end up screwing up on the security properties of the system. But then the second piece is we've got the data. We're trying to publish it as well as we can and find interested grad students who want to do some more research on what that data shows. And then at the very end, there are some performance questions. That's certainly what Damon and Kevin are interested in working on for the next year or so. How do you make Tor faster than it is right now? Okay, so far so good. So here are some examples of why individuals around the world use Tor. So blogger Alice. A couple of years ago, there were 2 people in California who guessed about what Apple was going to come up with next, and they blogged about it, and it turns out they were right. And Apple sued their ISP to figure out who they are so they could shut them up. And one could argue that maybe Apple should have asked its internal employees, okay, guys, who leaked this information? But they found it cheaper and easier just to go after the ISP and make the bloggers be quiet. That sucks. I don't want to live in a world where large corporations find the easiest avenue to controlling their PR issues is silencing individuals on the net. 8-year-old Alice. Let's say your sister or your friend logs into a chat room, and you've trained her very well. You've said, don't tell people your name, don't tell people where you live, don't provide personal information. Before she says anything, she immediately broadcasts her IP address to the other people in the chat room. And it's not so hard to turn an IP address into a set of geolocation coordinates, and it's not so hard to turn a set of geolocation coordinates into a Google satellite map. I'm told from the Google people that we'll have real-time video in not so long. So before she says anything, I can figure out whether there's a car parked out front of the house or not. That's fundamentally broken. By default, the internet should be providing some level of default privacy, safety, security, anonymity, traffic analysis resistance. And then you should have the choice of how much personal information you want to reveal on top of that. So by default, there should be some layer of privacy, and then you can choose what to share beyond that. Or sick Alice. Let's say your parents have diabetes, and you're not really sure what that means. And you learn about it from your internet connection at work, and suddenly you get fired because somebody monitored that and said, he's going to cost me more in healthcare next year, let's get rid of him now. And this happens every month or something in the US. I was just talking to somebody who was very upset that it happened in Finland. Finland is part of Europe. They're supposed to be good with that whole privacy thing. They're supposed to be good with that whole healthcare thing. Nonetheless, somebody got fired for researching something on the internet and looking like they were going to be sick later on. Or consumer Alice. Let's say you like to race cars. So you go to Amazon and you look at a bunch of books on car racing, and you don't buy anything, you just look at a lot of them. 3 years later, you go to get car insurance. Your insurance company says, do you like to race cars? You say no. They say, what about those books you looked at on Amazon 3 years ago? Is that crazy talk? I have no idea. All of these large corporations are collecting all these huge databases. They're not really sure how they're going to monetize them. We're going to find out in a few years what they're planning to do with this sort of thing. So the goal with Tor is not to force everybody to be anonymous all the time. The goal with Tor is to give you an option about what personal information you want to be putting into all these databases that people are collecting. And then the network can track also. I was talking to somebody who went to an ISP conference a few years ago, and there was some guy from an ISP who was bragging about how much data they collect and how much money they make off of it. Apparently, I don't know if it was Comcast or Verizon, but it was one of the pretty big American ISPs. Aggregate your click logs and sell them. And they're not very specific, so they only get like 40 cents per user per month. But hey, free money. Why wouldn't you sell the personal information, the browsing history of all of your users? And then businesses care about, yes, question.
It seems like, in my sense, you can correct me if I'm
Yeah, so the question is, how much of Tor is working on technology versus advocacy, education, user explaining, that sort of thing? And we try to do a good combination of both. Many years ago, when we didn't have very many users, I was thinking to myself, how do I get people to care about this stuff? Because there are all these risks and nobody understands them very well. How do I explain it so that ordinary people realize that there are issues? And in fact, my adversaries are doing a great job of that for me. So every day there's another person who reads a New York Times article about NSA wiretaps America, or AOL publishes 50 million search queries and stuff like that. So there are more and more people who are realizing that privacy on the internet is really screwed up right now. And at this point, we have more users than we can handle. So it would be good to have the rest of the world understand what the risks are, but from a pragmatic perspective, if we can keep the first 500,000 people safe, we're doing a lot better than we would have been doing. And it would be great to teach more people that they need it, but there's a balance here because the Tor network has only a certain amount of capacity, and the capacity is a function of how many people volunteer to relay traffic. Speaking of which, somebody here should set up a Tor relay at UCSD. I'm sure you can get a faculty person to help sponsor it. So we want to do advocacy and education, but we need to balance that with actually providing safety to the users that we have right now. Did that answer that? Great. Okay, so those are some examples from the individuals and why ordinary people use Tor. Corporations also use Tor. They need to, for example, check out the competition to figure out which pages they're looking at on our website so that, let me rephrase that. A few years ago, back when I worked before Tor on a startup, one of my jobs was to go through the weblogs every day and send a summary of the weblogs to the salespeople so that they could call back the people who'd spent a long time looking at various product pages and saying, hey, it looks like you spent 8 minutes looking at this product page. Can I give you a little bit more details about this product? Would you like to buy it? They quickly learned not to phrase it that way because that really freaked people out. But that's a standard way of doing business these days, where you watch your weblogs and you figure out who's interested in what and you go from there. So if you want to check out the competition without revealing all your interests everywhere you go, then Tor is a useful approach for that. Another example of that, Google wants to put all of its corporate traffic over Tor so nobody can figure out what the CEOs are researching at this point. And if we could make it scale to that point, then maybe that would work well. What are your engineering department's favorite search terms? Who's talking to the lawyers these days? Another fun example there, let's imagine all the engineers at Cisco are looking for a new job today. Monster.com knows this before anybody else does. Do they sell it? Would we even know? Law enforcement cares about the same stuff for the same reasons, but they phrase things differently. Let's say you want to investigate a website and you don't want .mil or .gov to show up in the weblogs. Or let's say you want to do a sting operation. It turns out if you show up in a chat room and you say, hey, I'm 8 years old, I really want to meet you on the street corner, and you show up from an FBI.gov address, it doesn't work very well. So I've been doing a lot of talks lately for law enforcement, and pretty much every talk I do these days, some FBI person comes up to me afterwards and says, I use Tor every day for my job, thank you. So another example, anonymous tips. I was talking to the folks who run the CIA anonymous tip line. It's called the Iraqi Rewards Program. The idea is you're some guy in Baghdad, you see a roadside bomb set up, so you go into the internet cafe, and then you go to CIA.gov and you click on, I want to submit an anonymous tip. And they promise not to remember who you are or where you sent it from. I don't believe that for an instant. They need to try to analyze where their tips are coming from. And the bad part there is anybody watching the network connection gets to learn that you are the guy submitting the anonymous tip. So wouldn't it be good if the people on the submitting side had the ability to control for themselves what level of security they get? And the people running the website aren't crazy. They realized there was something wrong with this security model. So now they use SSL. So now you go into the internet cafe and you have an encrypted conversation with CIA.gov. This is maybe not any better. Governments care about the same stuff for the same reasons. What would you bid for a list of Baghdad IP addresses that get email from .gov? Does anybody else out there want that information? Another fun example, one of the Naval Research Lab people who does a lot of research on Tor whenever he goes out of the country, he gets all sorts of training. Don't wave your American flag. Don't shout, "I love America." Don't wear your Yankees baseball cap. He gets no training. Don't log in directly to your Navy.mil email account. So he goes up to his room, he checks his mail. Anybody who's watching the hotel's network connection, or if it's a small Eastern European country, then the people watching their border gateway routers gets to learn, this hotel, room 806, U.S. Navy guy. Is that the sort of thing you want to be broadcasting wherever you are? What does the FBI Google for? Google knows. The FBI's ISP knows. Major telcos in the middle like AT&T know. I guess that means NSA knows. Who else gets to learn this sort of thing? And then journalists and activists care about the same stuff. I originally wrote this slide for a Department of Justice talk, and I titled it "Journalists and Dissidents Need Tor," and they got really upset. So I changed it to activists, and now they're totally fine with it. So it's really, again, about how you phrase things for people. So there are a lot of different examples here. Again, this is a separate talk. Activists and whistleblowers. Maybe your ISP is monitoring you. They want to know, did you just connect to this blog website? Or maybe the blog website is monitored. Maybe Blogspot is being watched, and they want to know which countries or who the individuals are that are posting to the blog. LiveJournal has a thriving Russian dissident community. It was purchased by a really rich guy in Moscow, and now they run the infrastructure for the thriving Russian dissident community. This is perhaps not what people had in mind. Another example, Yahoo.cn a few years ago had a user who was a little bit critical of China, and China went to Yahoo and said, tell us who our user is, we really want to make them a better citizen. And China said, and Yahoo said, why certainly, you are a government, we follow the laws of all governments, here's your user. And that got a lot of people in the US upset, but I mean, what are you going to do? It's a country like all the other ones. If you've got operations there, then of course you follow the laws there. So now everybody's moving out of China to Taiwan and Hong Kong, but how far are we going to move? Is everybody going to end up with all their data servers in Iceland? And we hope that Iceland stays okay? I don't know how that ends. Okay, so the big picture is you can't be anonymous by yourself. I was talking to somebody from IBM long ago who was saying, well, this is great, but I just want to run the IBM anonymity network. I don't want anybody else to be using my network. And if you're the only people using it, then you don't have anybody else to blend with. So the idea for Tor is put all these different groups into one shared network, so you can't tell if the person popping out is a cancer survivor or an FBI agent or an Iranian activist or a soccer mom or what. So far, so good. Yes? So there are a couple of answers to that. The question is, but aren't you suspicious already simply because you're using Tor? And the first answer is, even in places like China and Iran, we have 50,000 or something people using Tor. And that means that they don't know if most of them are reading things and a few of them are publishing things, then you've got quite a bit of a crowd to hide in. And they're not in China going to arrest everybody who is trying to get around the firewall. China's goal is to remind people that they're in charge, not to hunt down all the people who don't like the current government. Because if they kept on hunting down and killing people who don't like the current government, there would be more and more of them, and eventually they wouldn't be in charge anymore. So China walks a much more fine line than people expect. Certainly if you're in North Korea and you're lucky enough to be using a computer, then you're screwed if you use Tor. But there are a lot of places that are in between where the volume of Tor users means that the average Tor user is actually not a dissident. It's just some guy who said, I want to be able to get to my webcomics, which you blocked for some reason, so I'm going to use Tor to do it. So that's the first answer. The second answer is, in another 15 slides or so, I will bring up a design concept called Tor bridges, which are like the normal Tor relays, except not in any public list. And that means that you're able to reach the Tor network in a way that it's hard for other people to realize that that's what you're doing. Okay, And bad people also need anonymity. But if you're willing to break the law, you've got a lot of other options. In fact, a lot of them can actually provide better security, anonymity, privacy than what Tor would do for you. So break into a computer in China and route through that. Use the open wireless down the street. Steal a cell phone, use it, throw it away. Here's a brief taxonomy of bad people on the internet, which is a separate talk. But you start with your Trojans and your viruses and your exploits, and from there you build your botnets, and from there you profit. So part of the challenge here, there are really two scenarios. Scenario one, I would like to design a system that 1 million people can use. I can tell you how it works, and it still works a year from now. That's Tor's problem. Scenario two, I would like to come up with a cool trick that works for 20 people for the next 2 weeks, and I'm not going to tell you about it. That's generally the problem that the bad people have. The bad people are doing great. Their problem is way easier than ours. They've got a lot more ways of solving it. So, for example, the story about the 9/11 hijackers was the way that they were communicating safely on the internet was one of them walked into a library, logged into a Hotmail account, drafted a mail but didn't send it, and walked out. Somebody else walks into a different library, logs into the same Hotmail account, pulls up the same draft. No email is sent, therefore no email is logged. I'm told that this particular story is false, but it's a good example of a trick like that. And, I mean, you go to eBay and post your story, and then somebody else reads it. I mean, you go to a wiki. The list goes on and on of ways that people who don't have to scale and don't have to explain the design can get some sort of privacy. So far, so good? Okay, so how do you actually build one of these? The easy answer is you put a computer somewhere and all the stuff relays through it, and you're good to go. The problem with that is what happens if the bad guy in the middle doesn't provide the privacy that he promises? And again, this comes back down to the privacy by promise or privacy by technology approach. I was actually talking to one of the anonymizer.com people a few years ago, and they said, oh yeah, we never answer subpoenas. If we ever answered subpoenas, then our business model would be sunk. I mean, nobody would ever trust us again. So I was doing a talk for the Department of Justice last year, and one of them interrupted me partway through and said, why can't you be like Anonymizer? It's great. We send them a subpoena, they send us an answer, it's all set. Why can't you be like that? So I don't have a good handle on which one of them or both were lying to me, or maybe the statements were compatible in some way that I don't understand. But the goal of Tor is to not worry about that. We don't want to be in a position where you're trusting somebody who says, oh, it's in my interest not to screw you, but I could. It's worse than that. Ignore the relay in the middle and just pay attention to the stuff going out and the stuff going in. And there are some very straightforward statistical attacks where I can correlate this Alice was talking to this Bob. So basically, if I can see the traffic, then I can line up which user is talking to which person. And in fact, in the case of a centralized relay, it's one Ethernet connection that goes into the box, and it's the same Ethernet connection that comes out of the box. If I can get a job as the janitor at the Colo building, then I'm a winner. I'm done. So it's worse than that. So the goal of Tor is to distribute the trust over multiple hops. So no single relay gets to learn about both Alice and Bob. So if R1 is bad, if R1 is trying to figure out what's going on, R1 can see Alice, but he doesn't know what she's doing. And if R3 is bad, then R3 can see Bob. He knows that somebody is talking to Bob, but he doesn't know who is talking to Bob. And if they're both bad, if R1 and R3 are colluding, then we're screwed. Because then they can start doing timing attacks and saying, hey, wait a minute, these patterns that I see at the beginning of and the end, they match up. I'm pretty sure that it is this Alice talking to this Bob. So we don't totally solve the anonymity problem in that if you're in a good place to beat the system, then the math is pretty easy. So that means that the security of the Tor network comes from having a diverse and dispersed set of these purple boxes. The more relays we have and the more different places they are, the fewer adversaries exist who can be in the right place to beat the system. So if we have 5 relays and they're all in New England universities, then level 3 is a global adversary of the Tor network. But if we've got 2,000 relays and they're on 6 continents plus a satellite, then the set of people who are in the right place to be able to monitor things gets a lot smaller. So far, so good? And there's crypto, but I'm not going to talk much about that today, except to point out one thing. This line right here from R3 to Bob, Tor does not magically encrypt the internet. This confuses a lot of our users because they say, I have installed a security tool, now I am secure. I can do anything, and I will be safe no matter what. And Tor provides encryption all the way through the network, except what pops out of this third hop, what pops out of what we call the exit relay, is whatever Alice sent. So if she's logging into her /dot account using plain text, because /dot does not support SSL, then Bob gets to learn that password, R3 gets to learn that password, and anybody on that network connection in between gets to learn the password. And maybe the answer is everybody in the world should use SSL. Maybe the answer is everybody should at least understand what the problems are. That's a whole separate talk, and it doesn't end well. Okay, so what do we as Tor spend our time on? We've been working on a lot of different things lately. One of them is performance and scalability. We need to make the network able to handle more load and handle the load that it currently has better. There's more and more pieces of the software ecosystem that we're trying to support. For example, we've been helping the Firefox people maintain Firefox in a way that doesn't screw up user privacy. We've been talking to the Chrome people as well about what sort of APIs they should provide so that we can write something for Chrome that will keep you safe. We started out using a library called libevent that wraps select and poll and other stuff for you, and now we are maintaining libevent because nobody else is maintaining it well enough. And we've been fixing bugs in OS X, and the list expands of what different pieces of software we try to make sure we can keep safe for you. And then there's the whole blocking resistant circumvention stuff. Turns out if you build a really good anonymity system, but people can block connections to the anonymity network, then who cares how good it is? So we've been working on ways to make it harder for people in China or Iran or Boeing or whatever censored environments you happen to be in to block users from reaching the network. And then there's basic research on anonymity. How much do you get? How do you get more? If I give you this configuration or that configuration, is this one better? Against which attacks is it better? And then there's reusability and modularity. In general, we really want Tor to be a generic tool for building overlay networks. You give us the set of relays, and we'll build safe paths through them and do all the encryption and so on. And that means that you can come up with your list of relays however you want. We have a simple way right now, which is a centralized directory infrastructure, but there are plenty of other ways you could do it. And then advocacy, education, trainings around the world. I did a fun talk in Hong Kong last year for a lot of activists. And then after one of my talks, I met with an actual honest-to-God Chinese dissident who wasn't willing to come to my talk. So there are a lot of interesting people out there. And then metrics, data, and analysis, as I'll talk about in a bit. So that was the end of talk number either 2 or 3, and now I'm going to do a 6-minute version of the whole censorship, circumvention side of things. So the first key thing to think about, most of the people working on censorship-resistant tools, on circumvention tools, have been thinking of it in terms of how do I get a new address to the user? And then the bad guy's goal is to enumerate all the addresses and block them all. And Tor started this looking at it as there are 2 pieces to this whole problem. The first piece is the relay component. How do I build the circuits if you give me the list of relays? And then the second piece is the discovery component. How do I give some addresses to the user so she can bootstrap or so she knows what to connect to later? Tor has spent most of its energy on the first piece, which most circumvention tools ignore. They say, we're going to build a proxy, and then the whole problem we have to solve is how do we get the proxy address to the user? And Tor sort of comes at it from the opposite direction of, we've got this really snazzy multi-hop security proxy thing, and now we need to solve the discovery problem, and we can keep that independent from the first one. How the Tor design works has nothing to do with how you learn the relays. Okay, so there are a bunch of different ways that bad guys can block connections to the Tor network. The first one is we've got these centralized directory authorities I was talking about, and there are 8 of them. Their IP addresses are hard-coded in the code. So you grab those IP addresses, you block them, you're done. And if that doesn't work, pull down the list of all 2,000 relays and block those. And if that doesn't work, start looking at a Tor connection on the wire. Tor tries to look like SSL, but there are a few ways in which we look different, and we need to keep playing the arms race in that direction. And then if that doesn't work, torproject.org, block the website. We got blocked in China a few years ago, and there were a lot of people at that point who were saying, well, that was nice. Tor was good while it lasted, but I can't get to the website, so I guess it doesn't work anymore. And the software worked fine, but the website was unreachable. So we lost a lot of users at that point. Okay, so the bridge design that I was talking about earlier is we've got all these users, and many of them are in uncensored areas. We've got something like 500,000 of them. Some of them are unreachable because they're behind, but a lot of them are reachable. So the goal is to turn a lot of the users into bridges, so somebody inside China goes to one of the users, and then from there to the rest of the network. And that means that the bridges, the Alices, the users here, don't know what the blocked users are doing because we still have that distributed trust multi-hop thing going on. And they don't have to be exit relays. The bridges never have to be in a position where they're actually sending mail to somebody or delivering content to the rest of the internet, so they're not going to get abuse complaints. And they don't have to relay that much traffic. 20 kilobytes a second is great for somebody in Iran who otherwise has nothing. So the key point here is for these purple boxes, for the relays, the key critical resource is bandwidth. But for these guys, the critical resource is quickly changing IP addresses. So we either need a whole lot of bridges so we can quickly change which IP addresses we're giving away, or we need a lot of bridges on DSL providers that can quickly change their IP address, or on Amazon Cloud that you can rotate through a lot of their /16s pretty quickly. So that's an ongoing question of how do you distribute the bridge addresses in a way the bad guys can't learn all of them. But we started with the problem, how do we publish 2,000 IP addresses without letting the Chinese government learn about them? And that's an impossible problem. The new problem of how do I take these 500 or 1,000 or 50,000 bridge addresses and give them out one at a time to the good guys without the bad guys learning all of them is a hard arms race, but hopefully an easier one. Okay, so how has that actually been going in practice? Here's a graph from last June of the number of users we saw connecting to the Tor network from Iran and from China. So here's where the election actually happened. And then it spikes up to here, and then there are a lot of people doing protests, and then it falls off again as the urgency of telling people what you just saw on the street or learning what coordination is going to happen next goes away. And for contrast, I put China on the same graph because during that month of June, all the newspapers were saying, Iran, 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 Iran. But at the same time, there were many more people using it in China than there were in Iran. So over here is the Tiananmen Square anniversary. They call it May 35 because they're not allowed to talk about June 4 in their country. And so there were a pretty good spike at that point. But the real spike happened here where China decided to block Google.com, Google Search, Google Groups, Google News, Google Calendar, a few other things. And at that point, there were a lot of people in China who used to be saying, I'm so glad my government keeps me safe on the internet. I like the fact that they firewall me. And then they were saying, holy cow, my government censors the internet. They're blocking Google. This is not cool. I need to learn how to get around that. And one of the neat things is that China keeps sort of censoring things and then backing off to remind people who's in charge. But every time they censor them, another 100,000 people learn how to get and use circumvention tools. So they're actually training their populace through this arms race to be able to get around whatever censorship they do. Yes? How do we collect this data? So that's not a quick question, is the first answer. The brief version is, so going back to the slide a few slides ago with Alice, R1, R2, R3, R1 can see that Alice is using the network. It just doesn't know what she's doing. So the very brief version is we teach the Tor relays to look at the set of users they've seen, aggregate them into countries, and then publish China 6,000, Germany 4,000 in 24-hour increments. Separately, we teach the bridges to do the same sort of statistics. And I'll get to that in this slide right here. These are the number of people using bridges in that same time period. So there are a lot of people in Iran using bridges and basically nobody in China. For both of these countries at this point, you didn't need bridges. The Tor network worked directly. So you just connect to Tor and you're all set. But for a lot of people in Iran, we were trying to teach them, first of all, they might block the public Tor relays. It's not hard. Eventually they're going to do it. And when they do it, you're going to need a bridge already, or you're not going to be able to keep using it. And second of all, they might not block them. They might monitor them. They might build a list of all the Tor users. And I don't know if it's safe or unsafe to use Tor in your country, but you should realize that if you think it's unsafe, here's a way to make it safer. So there were a lot of people who were using bridges, even though they didn't need to for reachability. So ask me your question about how we aggregate this data safely afterwards, and I'll chat with you a lot more. So that was the good news. This is the bad news. September 25, in the lead up to the October 1 60th anniversary of some guy becoming in charge in China, they blocked all sorts of stuff. So here's one relay in Amsterdam. It was seeing 10,000 people a day connecting just through it. And suddenly on September 25, it flatlined. And then there was a hiccup where they screwed up their firewall, and then it flatlined again. So that was kind of sad, because up until that point, we'd been asking ourselves, are we doing the right thing politically? Because we've managed to position ourselves in a way that China doesn't feel the need to block us. And then we got too popular. We'd been trying really hard not to have front-page New York Times articles, because every time I talk to a journalist, they all want to write, Tor project declares war on China as their front-page article, or lone American hacker conquers communist nation. These are fantastic articles for Western press, but they do not help our cause in any way, because the only people who read them in China are the folks who have policy influence over the firewall. So they go to the people who run the firewall and say, hey, I just heard about this Tor thing. Have you taken care of it yet? So the fewer of those huge media articles we have about that topic, the better off we are. So that's the bad news here. But the good news is we had already deployed the bridge design on the theory that this would happen eventually. And here is the same graph, the number of people using bridges. So basically 30,000 people switched to using bridges over the course of a week. So through word of mouth or whatever was going on, a lot of people learned, okay, Tor doesn't work, but if you do it this way, then it does. Okay, so another set of messes that comes up, all the application level issues. There are so many different ways, cookies, history, browser window size, user agent, what language you prefer, all of that you can screw yourself when you're attempting to interact on the web through Tor. Tor by itself just hides the IP address that your traffic is going to or coming from. What you say is up to you. So for example, if you do a blog post and you put your name on it, that's pretty intuitive. You know you might have screwed up. But your browser does a lot of much more subtle versions of exactly that. And we need to try to keep you safe. And it's worse than that. There are a bunch of plugins that are even more messy. A while ago we had a problem. So the way that plugins work on Firefox is you click on a URL that ends in .pdf, and your browser says, oh, I have a plugin that's registered for .pdf. I'm going to hand that URL to the plugin. And so the Adobe PDF plugin says, oh, a URL. I think I'll fetch that. What's a proxy setting? So that means that you may have configured your Firefox correctly to proxy through Tor, but Adobe PDF had no clue it was supposed to look. And so another bad example there is Flash. If I go to a website over Tor, it hands me an arbitrary binary, which I run. That arbitrary binary looks up my IP address and sends it back to the website. Tor is doing its job. Tor is anonymously sending my IP address back to the website. But this is probably not what most people wanted to have happen. It gets worse than that. Did you know that Microsoft Word is a network application? If I embed an image in a doc file with enough backslashes in front of it, it turns into a NetBIOS call that bypasses all the system-wide proxy settings and goes directly out to that website to pick up that image and put it inside the doc file I'm trying to display. Basically, if you use Windows, you're screwed. And it's a separate talk about how to make you slightly less screwed, but there are no great answers. So the best answer we have right now is the Tor browser bundle, which is a big blob for Windows that includes Firefox pre-configured. You click it. If you can use it, it'll keep you safe. It doesn't include Flash, so no YouTube for you, which is kind of bad for the folks in Turkey who are like, I wanted to use Tor because they block YouTube, and now I'm using Tor, and now Tor disables Flash, so I can't go to YouTube. They don't say it that way. They say it as Tor doesn't work, or some other much more simplified version of that issue. We've been working on a Tor VM, sort of a network card approach, where you run a Linux kernel with a Tor client and IP tables rules inside your Windows machine, and it takes over your network. So all outgoing requests, even the NetBIOS call when you're loading your doc file, get shoved into the Linux kernel and into the Tor client. But it turns out to be kind of hard to write good networking code on Windows. If any of you are good at it, let me know. Another issue. Tor is only a piece of the puzzle. If you have spyware installed, we cannot help you. And there are a lot more versions of that out there. If you are using the village's Windows 98 computer in the middle of town and it has a keylogger on it, we cannot help you. Beijing a little while ago had a law saying everybody using an internet cafe machine has to have a camera over their shoulder pointing at the screen, and you have to have a snapshot of their ID and all of that. So if there's a video camera pointing at your screen, we cannot help you. And it's obvious when you phrase it this way, but there are a lot more subtle versions of that out there. I was talking to a group of activists from another East Asian communist country a while ago, and I was all set teaching them about 40-bit encryption bad, 128-bit encryption good. Let me teach you about Firefox and PGP and Tor and so on. And they were getting phone calls in the audience saying, so-and-so just got arrested, what should we do? And it quickly became clear that they needed an OPSEC, not an InfoSec training, and we were maybe not the right people for that. And they were telling us horrible stories, like when I go to the bathroom, they break into my house and answer my Skype calls. So yeah, I use encrypted Skype, but we still have to have an extra protocol on top of that to figure out if we're talking to the right person, and sometimes we're not. There's a guy across the street with a parabolic microphone listening to everything I say. So yeah, I use encrypted Skype, but it still isn't enough. Publicity attracts attention. I talked about this a little while earlier. The first point is we can control the pace of the arms race by deciding how much to smack China in the nose. And the more subtle we are, the less they have to react. Because really for China, and there are a lot of countries and each of them is different, but in China's case, their goal is to maintain the appearance of control. So anybody who writes a big article or otherwise has a big social network spreading statements to the contrary needs to be stopped. So as long as we don't actually spread statements to the contrary and everybody happily uses it in a very subtle way, then we're all set. How do we scale the network? Right now, we need to make it so that every Tor client knows what the network looks like and has the same view of it so that they can blend together, so that they can get anonymity. Eventually, we're going to have so many relays that you can't afford to tell every client about every relay. How do you do that in a way that doesn't screw up your anonymity? Advocacy and education. Seems like there is an unending stream of people in the DC area who make critical policy decisions and do not understand technology. It also seems like every time I finish teaching them about technology, they go get a better job. So the people who stick around are the ones who are either so dedicated or otherwise don't want to end up in a better position, different position. So one of the challenges that I have is how do I teach policymakers, law enforcement people, journalists, and so on, what all these issues are. We've got some funding from NSF to work on aggregating data and collecting data safely. So the first part is we want to invent and deploy some sort of new algorithms and show that the data we're collecting is safe. The second approach is give the data to all of you and everybody else and help analyze it, provide tools that can read it in and crunch through it and do database stuff. The third one is what else should we be measuring in terms of performance data, in terms of user or relay statistics. And then the last one is there are a lot of research groups who are out there solving problems which are not actually Tor's problems. It's really easy as a professor or a grad student to say, well, Tor is slow. I think Tor is slow like because of this reason, so I'm going to work on solving this reason, when in fact that's not the reason why Tor is slow. So part of my other side hobby has been going to talk to a lot of researchers to try to answer as many Tor questions as I can so they're more likely to solve the right problems. So some interesting data that we've got in the last couple of minutes. Here are the number of people connecting from China to the public Tor relays. So here is that end of September blocking that I was talking about before. That was the first major block. And it flatlined for a little while And then we switched our IP addresses a little bit, and it started working again just fine. One of the weird things about China's blocking is they do it 4 times a year or something like that. In the lead up to some political event, they do a lot of blocking. And the rest of the time, they leave you alone. So we need to change our bridge distribution strategies, which currently expect an attacker who's working all the time against it, so that if they totally beat you in 1 week because they just put 30,000 people on beating you, then the next week you need to have addresses in reserve that you can come up with that you did not offer in any way for that previous week. So it worked fine for a little while, and then they flatlined us again, and it's looking pretty bad in China for direct connections these days. And here we have direct connections to the Tor network from Iran. And there are a couple of interesting things here. One of them is that we changed our GeoIP database so that we are more accurately measuring where users are coming from. And that's the difference between this and this. So in fact, this whole graph should be at the 15,000 users a day mark or something like that. The other interesting feature is this little blip right here. So when Iran had its whole June election thing, they turned off their internet for a little while because they needed to buy more equipment from Nokia. And if you look at the overall connectivity from Iran to the rest of the world, it's this really cool sort of step function where they add 1 gigabit at a time as they put in enough infrastructure to be able to censor and monitor that new gigabit. So they turn off their internet and they turn it on 1 piece at a time. And part of the features that they have in the shiny Nokia equipment that they got, they have a knob for protocol identifying SSL, and they turn down the SSL knob when they're feeling scared. And we designed Tor to look like SSL, because who would block SSL? And now we know the answer to that, because there's a fancy box in Iran that is able to block SSL when they want to. Now, they don't do it all the time, because it's bad for commerce and makes more people angry at them. There's sort of a weird continuum out there of different countries and how willing they are to turn off their internet. China can't afford to block very much because there are too many people using it for too many different things. Burma, on the other hand, step 0 of the coup is let's turn off the internet, and they basically haven't turned it back on again. And Iran is somewhere in between where they're willing to shut off parts of it and make things really bad, but they don't really want to turn it all off forever. Okay, so here are connections from China to bridges over time. So this is that big spike that you saw before, and then it goes up even farther, and then they block a lot of the bridges, and then we come up with a better strategy, spreading them through social networks rather than more automated ways. And then they basically beat us at the arms race as we are currently playing it. So one of our plans for the future, once we get our act together, is to deploy a different version of the arms race, and maybe we'll be in better shape. Another problem is that we only have 500 bridges total, and that's really not enough. The original question I had been phrasing it as was, we need to get a lot of bridges so that China can't learn them all. And what I should have been saying was, we need to make sure that the rate of change of bridge addresses exceeds the rate of blocking that China can sustain. So it's not about the number we have, it's about how many new ones we have versus how quickly they can block them. And looking at that in that way means that there are maybe better strategies than what we have been using. And then Tor users connecting to Iran over bridges? Yes?
So what gates the rate at which you can install these bridges? Is it a human thing? Is it finding the people who will agree to something on the mission?
Yeah, so the question is, how come you don't have more bridges? And the short answer to that is that we haven't told enough people that we need them. In the Vidalia interface, so the Vidalia interface is pretty simple. I want to set up relaying. I'm in Russian right now, so I'll switch it back to English so you can see the text. So I want to set up help censored users reach the Tor network. Boom. If I click OK, then I'm a bridge. Nobody has ever told people to press this series of buttons, at least not very well. So a lot of people don't even know that the whole bridge concept exists. One of the things we've been meaning to do lately is set up a separate download, which is already pre-configured to be a bridge. and already maybe in the language that you prefer. I know a fellow in Los Angeles who helps with a radio show, and he's also a big Iranian activist. So he, at some point, is going to start saying, hey, if you want to help save the world, then download this thing and run it, and then you'll be a bridge. Another part of that is we've been working for a while on having the Tor client recognize when it's reachable and has enough bandwidth, and it should automatically turn you into a bridge. And then we would, rather than having 500,000 people who could be bridges if only they knew, then we would get, I don't know, 40,000 or something of them, whoever is stable enough and reachable, and then we'd have a lot more. But again, the set of addresses we have might not change as much as they should. If we've got 40,000 people and they're the ones that are reachable, maybe they're on static Comcast IP addresses, and once they're blocked, we have no use for them anymore. So there's a lot more thought that needs to go into that one. Another thing we've been pondering, Amazon Cloud apparently has an API that lets you swap IP addresses. So we should set up a couple of bridges on the cloud, have them automatically learn when they're blocked, and have them just smack the big red button whenever they need to become a new bridge. You could. China has shown a remarkable non-interest in over-blocking. If you put a bridge here, then they block that IP address. And you put it next door, they block that one. And a while later, they unblock the first one. So they're really trying to be very precise. So, I mean, that's part of the challenge in general of looking at this from a computer security perspective. Because we, as security people, say, well, China could do this. But they don't. So we need to take advantage of what they're not willing to do and understand better why they're not willing to do it. I mean, part of the challenge of this, when I'm talking to a lot of other security people, is they say, so wait, China has billions of dollars, and they've got 30,000 people working on this project, on this problem. So if I were China, I would round up 10 Tor users in China, publicly kill them, and repeat until nobody's willing to use Tor anymore. And people from China laugh and say, oh, that's funny, they'd never do that. But computer security people are like, what? What's wrong with that algorithm? That sounds like a fine algorithm. So the answer is that China walks a much more fine line in terms of what they're able to get away with in their country. And they can't just kill people for no reason. So again, they also walk a fine line where the goal of the firewall is to remind people who's in charge not to block everything. So if you get around the firewall, but that's because you're really good, fine, go ahead. The other side of that, going to a non-China country, one of the weird things about Iran's firewall for the past year, certainly in 2009, most people who worked for the Iranian firewall did not like firewalls. So they didn't block anything. And this also happens in China, where they say, I run the Chinese firewall, but I'm going to do the minimum I can do to keep my job. And I don't want to block that. Why would I want to block that? So if they get enough pressure from above to block something, then they will. Otherwise, they'll leave it alone. So in Iran, for months, I speculate that there was some guy saying, yeah, I'm working on blocking Tor, but it's hard. And he got away with it for months. Sounds great. So there's a lot more politics and social interaction going on here than just what the algorithms would be. So far, so good? We've talked to them. Yeah, we've talked to them a little bit. The BitTorrent people, for example, were wondering if they should ship a Tor client in the BitTorrent code. And that would be an adventure all around. We haven't really gotten to the point where that's probably the best way to do it. We were also talking to one of the other file sharing people. I don't remember which one, but they've got 50 million users or something, and you ship a little bit of Tor on some of them. And yeah, so this is a good idea that needs more exploration. So these are, let's see, the number of connections into Iran over bridges is basically zero over time. It's a few hundred people, and that's because Tor works the whole time. There's no need, though again we have that little dip right there where they turned off Tor, which is kind of a scary dip. So I'm 2 minutes over, which means I'm going to run through a few more slides. Nobody's actually gotten up and left. Does that mean I should keep going? Or? Okay, well, sounds good. I'll slow down then. Yes?
So I was just curious, do people ever attack the relays?
What do you mean by attack the relays?
I'm just wondering if there's any disincentive for actually becoming a break. Or, say, oh yeah, I want to hack the client inside, get one or something. Well, maybe you don't want to do that because people realize.
Most of the disincentive for becoming a relay is that you use bandwidth that you could use yourself. If you're an exit relay, then people do attack them. And generally, it's not because they want the Tor network to go away. It's because some guy exited on an IRC and made fun of somebody else. And what you do on IRC when you're made fun of is you try to knock the guy off the network. And they didn't even know that it was a Tor exit node they were trying to knock off the network. So I get mail from BU every so often saying, I'm being DDoSed. Is anybody else being DDoSed? And the answer is no, usually it's just you. So there have been no coordinated DDoS attacks on the whole network. But periodically people do try to knock off individual relays without even knowing that it's Tor they're attacking, I think.
Is there a current accepted interpretation of whether Tor operators have common carrier privileges? If I run an exit node, what liability do I have in the US or other countries with respect to my traffic that is now leaving my...
Yep. So this is a fine open legal question, and we have a lot of interesting ACLU, EFF, and Berkman lawyers looking at it. Some of the laws that were written within the past 15 years actually look pretty good. For example, the DMCA has an explicit safe harbor 512A for people who are transiting bytes. So just as ISPs are not the people at fault for somebody breaking the DMCA as one of their users, so too are the Tor relays not at fault. And the way that the law is phrased is you need to have a policy about what you do when you get a DMCA complaint, but your policy can be, I have a policy, and you're done, you followed the law. So with respect to the DMCA, you just throw away all the complaints, and they don't apply to you. And in fact, one of the EFF lawyers has been pondering doing countersuits about DMCA complaints, because if you knowingly send a DMCA complaint and you knew that it didn't apply, you just broke the law. But that's DMCA. There are a bunch of other laws which were written earlier, which nobody knows what the heck they mean with respect to the internet. So if you dig deep enough and you are conservative enough, you will find laws that could mean that you're liable. But if you're not that conservative, you won't find any. Another way to answer that is there have never been any people in the US found liable for their Tor relay. In Germany, there was a case a while ago where somebody was found liable for the traffic that went out of their open wireless point. So it's hard to know what is going on in Germany. There have been no people found liable for the stuff that comes out of their relay in Germany, but the German law enforcement are much more eager to kick down doors in Germany than in the US. We've actually made a lot of progress in the US educating FBI and other law enforcement people. So now when they send you a subpoena and they say, it seems your computer did this, can you give me more information? Then you say, no, I'm sorry, it's a Tor exit relay. And then they say, oh, okay, thanks. And in Germany, they don't say, oh, okay, thanks. They say, okay, well, the law says I have to come kick down your door, so I'm going to come kick down your door, and I'm frustrated that I don't get any information out of it, but I still have to come kick down your door. So one of my side hobbies, again, has been talking to law enforcement all around the world to try to teach them what this internet thing is. And we're doing a lot better than we were, not just because of Tor, but because of the general internet infrastructure. 20 years ago, if your computer did something bad, then they would kick down your door and arrest you and say, we know you did the following. And now what happens if your computer does something bad is they knock very politely and they say, it seems your computer has done the following. Do you mind if I take a look at it? So in that sense, Microsoft has paved the way for FBI to have a better understanding of internet security, because it's usually a Windows computer that's been compromised and is being run by somebody else. So they're looking for evidence. They're not trying to bust you. So Tor benefits from the fact that Microsoft writes crappy software in the people who are investigating things no longer make bad assumptions. So far, so good? Okay, so other fun things to look at. We, just a few days ago, finally added up all the various graphs of number of people connecting to the public Tor relays. And it's hard to know if this is right, but it's probably right within an order of magnitude. We've got something like 500,000 people, give or take, connecting to the Tor network every day. And by people, I mean Tor clients. So another fun graph. Here are the set of connections from South Korean IPs to the Tor network. Every weekend, it goes down to 20,000 people. On non-weekends, it goes up to like 80,000 people. Why is South Korea not needing Tor on the weekends? People at work are, yeah, so, I mean, what are they doing at work that they aren't doing on the weekends? Interesting questions. Russia has a similar pattern, but it's less obvious. Iran has a similar pattern. Germany and a bunch of other places don't have this pattern. Good question. Somebody should ask more people in South Korea what's up with that. Yeah. There's a friend of mine who now works at NIST has been asking me for quite a while to do the rump session talk where rather than saying, we have data, let me tell you about our aggregated anonymizing metrics, instead say, we've got data about Tor users, and let me tell you a little bit about it. For example, we've got this number of people from China. Let's do a case study of Maurice from Florida. Why does he use Tor? So I've so far resisted doing this talk because I think it would confuse more people than it would help. But there's a lot more to be learned out there. Right now we do it mostly anecdotally, where I find people at talks and they say, my brother is the mayor in a small city in Maine, and I am the town's lawyer, and I have a blog, and if anybody learned that the blog is my blog, then the whole town would be talking about it, and I wouldn't be the respected central person that I am, so I'm so happy that Tor exists because now I can have a web presence that's not associated with my small town real life. So all of these are anecdotes that people tell us like that. Okay, number of bridges we've had over time. It started out with not very many years ago, and then we got slashed out a few times, and then we ended up with a lot when I went to Germany and did a talk at the Chaos Communications Congress. And then over the course of this time, there were two problems. One of them was we had a bug where relays on dynamic IP addresses didn't notice that they changed, so they just went away. And at the same time, there was the whole data retention question in Germany, where the law said something like, if you're a service provider, whatever that is, you have to keep logs, whatever those are. And a bunch of technical people are like, what the heck does that law mean? Am I liable? Should I stop? And being Germans, they all did the conservative thing and stopped. Not all, but quite a few. And then it became a little bit clearer what was going on there, and we fixed our bug. So I'm not sure which one fixed it. Here is the election thing in Iran, where a lot of people in the U.S. said, I'm going to help save the world. And here's where all the people who were running Windows decided that saving the world wasn't actually very fun. And then we have a problem here where I had a bug where we rolled out a performance fix that was actually an anti-performance fix, and it was causing all of the clients to mob all the fast relays, force them to run out of file descriptors. They fell over. The mob moved to the next one, mobbed that one even harder because there was a higher concentration of clients attacking it. And so I guess to answer the question from earlier, have there been DDoS attacks against Tor? No, but once you build a user base of 500,000 people, then an innocent-looking bug can look like you're DDoSing yourself. So there are a lot of systems issues with once you've built a network and there are a lot of people using it. And another way of phrasing that is, I don't worry at all yet about building DDoS resistance into Tor, because right now the fact that people are using it looks like it's being DDoSed. Let's fix that before we worry about people actually actively trying to attack it. And then this spike was some fellow in a different New England university signing up 800 exit nodes from Planet Lab on one day because he wanted to try out an attack, and what better way to do that than to do it on the public Tor network. So one of the lessons there is there are a lot of people doing experiments on the public Tor network at once, and if we don't know about them, then your experiment is probably not going to answer what you want. Because we roll out performance fixes or change things or put out our own experiments. And if we're messing with the network at the same time you're messing with the network, and then there's a third person messing with the network, then you're not going to get the rigorous results that you want. So does that mean that we should have some sort of coordinated clearinghouse where all the people doing experiments on the public network tell each other about them? That sounds like a good start. That would also have the benefit where we could say, wait, you're planning to do what? Should you talk to your IRB first? Another fun pattern, number of relays over time changes from day to night. There's a 24-hour cycle where we've got something like 200 relays that appear and disappear. Okay, so that was the n-1th talk, and there's a little bit more to be said about performance. Should I spend 2 minutes on this, or everybody seems happy to stick around? What does that mean? Keep going. Okay, sounds good. So this is a graph from years ago, from like a year and a half ago or something, where we fetched a 50 kilobyte file over the Tor network 14,000 times. And we tried to figure out what the average amount of time it takes to actually fetch it was. So there are a couple of interesting features. One of them is there are a lot of them that are really quite fast, like 2 or 3 or 4 seconds or something. Another one is the median is 8 seconds. That's not great, but it's not horrible. And then check out this huge tail going off like this. So that's not probably the best situation, and this is one of the graphs that motivated us to start the Tor performance work. Because we're like, first of all, Tor is kind of slow, and worse than that, there's a really high variance of result. You might be the guy who ends up here with non-trivial probability, and then you'll be really sad. And maybe it's 2 seconds, and then it's 40 seconds, and then it's 3 seconds, and it oscillates even while you're using it, depending on whether somebody else is trying to BitTorrent through one of the relays you happen to use at the time. So that was one way of looking at it. A better way of looking at it, we've been graphing these 50 kilobyte results over time. So this is the graph of the Tor performance in the network for the past year or so. And here is where we rebalanced the weighting. So every client knows what bandwidth each relay advertises, and then they load balance based on that number. So they say, you're advertising 500 kilobytes a second, so I'm going to be 5 times more likely to use you in my path than somebody who's advertising 100 kilobytes a second. And those numbers are pretty good in that we load balance okay, but we re-weighted the numbers even better, and we managed to drop our latency from 8 seconds median to something like 4 or 5 seconds median. And then here are 2 instances where we disabled that feature to go back and use the old weights. And it looks pretty clear that, in fact, that helps. April is when all hell broke loose. So first of all, China unblocked the Tor network in April, which meant we had 100,000 or something people all showing up again using Tor. Second of all, I had that bug I was talking about where we were losing a lot of the fast relays. So we managed to fix that. And there's this fantastic period of stability right now where the Tor network is really very fast and not very loaded. Does that mean that not many people are using it right now? Does that mean that we made some performance changes and everything looks great? Hard to say. Here's yet another way of looking at that perspective. So this red line is the CDF of where those 50 kilobyte downloads go from August of last year, and the sort of blue-green line is August of this year. So we're doing a lot better, but we don't know why. And then the last thing to think about, yet another talk, but I'll skim over this very briefly, and then we'll do whatever questions you've got. So there are a bunch of different reasons why Tor is slow. This is a list that I wrote a year ago, and I'm hoping that I'm wrong on quite a few of them, but it seems like a good place to start. So the first problem is Tor uses TCP from pairwise TCP, from each relay to each other relay. And it multiplexes all of the circuits over that one TCP stream. And TCP has one plan when you're talking too fast, and that's to push back. And since we multiplex every stream over that one TCP connection, then if you're not talking very much, you get punished by somebody else who is talking too much. So it drops a packet, forcing the window to get cut down, and then even the instant messaging people are punished by the fact that somebody was talking too loudly. So that's the first problem. The second problem is some people are simply putting too much stuff over Tor. If you are BitTorrenting over Tor, then the solution to that is not, let's get the fairness better so you can BitTorrent all you like and it'll be even faster. The solution to that is, if you're BitTorrenting over Tor, let's cut you off at some small amount so that we're not adding all this load into the network in the first place. And maybe one way to do that, if we're moving to an end-to-end TCP model, would be to cap the window size at some amount so that it can never have a throughput higher than a certain amount. All of these are fine open research questions. Problem number 3, and I've ordered these by highest urgency, I guess, or the highest reason why it's a problem. Otherwise known as, if I solve 2 through 5 but I don't solve number 1, then we did not solve the problem. So number 3 is not enough capacity. We don't have enough relays. There are a bunch of people out there who run ISPs or have extra bandwidth or something like that, and they run a lot of relays, but we sure need a lot more. We've got something like 15 gigabits a second of capacity right now, which is pretty good, but the list of people on the internet who would like to have safe communications is way larger than that. So that's Tor performance in a nutshell, and I'm going to stop and take some questions now. Nope, that's yet another open measurement question, and it would be great to have more people looking at that. One of the questions is, what churn do we have for bridges right now? What churn would we have if we set it up on Amazon Cloud or something like that? And what sort of, another way of asking that question is, if I can tell the user n bridges, and I want the user to have at least one of those n available in 4 days when he comes back, what should n be given the current churn rate? And can I influence the churn rate so that n is a reasonable number? That's maybe another way of asking that question. So there's another design out there called FreeGate. It's written by a bunch of Falun Gong people, and it's entirely a circumvention tool. It's not an anonymity tool at all. But the design that they have is they have 2,000 volunteers running on DSL providers, and they're running reflash DSL modems. And so the modem itself runs the software, which takes care of the reachability problem because it is the IP address. And one of the neat features for FreeGate is when China blocks that bridge address, they block them duplex. So not only can China not reach the bridge, but the bridge can't reach China, which means the bridge checks Baidu every so often. And if it can't get to Baidu, then time to flip the switch. So they've got 2,000 of these volunteers, and they get a new IP address every 3 minutes. That's the rate of change that they are doing. And so the software that they have is constantly pushing reserve IP addresses to the users so that they will be able to fall back to the next one.
So, a number of these countries actually have significant IPv6 deployments.
Yes.
And so I'm wondering if you guys considered going to IANA and the various local registries and say, look, we now have an embarrassment of riches with respect to IPv6 addresses. We'd like a whole bunch of different chunks just to dedicate to this, and then people can sign up to the Connect Call B, which hosts those seem to be running all kinds of places on demand.
Yep. So that's a good idea that we have not investigated as much as we should. If all goes well, we're going to have a project with Paul Vixie pretty soon, and he can not only arrange to have the IP addresses pointing where they should point, but also run the infrastructure that they would point to. Basically, we would build big NATs that NAT these huge IPv4 or IPv6 spaces into more scalable Tor bridges which then push it into the Tor network. And yeah, so whether we should officially register them for ourselves or, so another version of that strategy, apparently there are a lot of people right now who own IPv4 space, but they're not using it. And people are looking at them funny because they're not using it. And if we could help them use it, then maybe they would like us. On the other hand, it might end up not working for China ever again. So there are trade-offs. On the other hand, going back to the FreeGate example, when China blocks the IP address for one of those DSL routers, and then they move away, China unblocks it a couple days later. So they're really trying to be very precise about what they're blocking. And that might explain some of the unblocking that I showed on a few graphs ago, where they blocked the bridges and then they didn't, and then they did. My theory there is that China blocked the bridge addresses, and then a week later they took out the ban, because surely they wouldn't be so stupid as to still be using those addresses. And we were, and we're like, we had been for that week thinking, what should we do? And then we're like, oh, they stopped blocking. It sounds good. We don't have to do anything. So we're playing the arms race in a very different way than maybe we should be. And they're having to adapt to the fact that we're not playing it as fast as some other people are. So that means that it probably wouldn't be too bad to loan us an IPv4 or IPv6 network, because we'll use it for a while, and when we're done, it won't end up ruined in the same way that loading a /16 to DEF CON ends up ruined. Certainly there's a concern of having a lot of relays in a not very diverse place. But having a lot of bridges might be okay. If the goal of the bridge is to provide new IP addresses that allow reachability into the Tor network, and it's the Tor network that maintains your anonymity, then maybe it's okay. Yeah. Well, not just exit, but as long as they are not... so every time you build a path, you either choose 3 public relays, or you use your bridge and then choose 2 more public relays. And because of some anonymity attacks, we should maybe change it so you're using 4 hops if you're doing a bridge. So it's bridge and then 3 hops for anonymity. And so as long as we don't have any single organization running very many of the non-bridge hops, whatever, first, second, third, then we should be in business. And I mean, every so often I talk to corporations who are like, I'm going to sign up 1,500 relays and help out. And I'm like, whoa, wait a minute. You should sign up 15 relays and see how that goes. And they never do. So I don't know if it's that they only think in bulk and they can't do anything small, or they weren't planning to do anything anyway. I don't know. I had a nice chat with the fellow running the Google Chrome project who was like, so what happens if I put a Tor client in every Chrome? And my answer was, well, the network falls over. And then he's like, oh, well, what happens if I put a Tor relay in every Chrome? And that's a much more complex answer. Among it is we have to solve the scalability problem of if you've got 500 million relays, you sure can't tell every client about every one of them. And then there's the whole abuse question of, did you really want to sign up a Chrome user to be the exit node for some other Chrome user? But, I mean, these are all fun research questions to think more about.
Way over time.
Sounds good. Thank you. And I'm around for the next 2 days if you have questions that you think of later.